All right, so we are going to just finish up that section R2, and it shouldn't take that long, and hopefully, if I stop talking, I'll give you time in class to work on it. All right, and we don't have class tomorrow, so you even have tomorrow, but there's no homework, so I'm not giving you homework today. All right, what we're going to do is we are going to talk about square roots. I think we talked about exponents last time, didn't we? Things being taken to positive exponents, things being taken to negative exponents. So today, let me move this thing around a little bit. So today we are going to talk about square roots. So let me see. There we go. Oops. Square roots. It's been a weekend. I lost touch of how to write on this thing. All right, so let's talk about that. So we have a symbol for a square root. Actually, this is really specific. When I say a square root, it's very, very specific. This thing right here, this little symbol, this thing right here is called a radical. Back in the 80s when I was in high school and college, that was like the phrase of the day. You ever hear that on like old movies and stuff? Anybody say radical? Like if something's really cool or wild, you say, wow, that was radical. You ever hear that before? Okay. Anyway, we actually used to say that kind of thing. I don't know how long it lasted. Yeah, rad. Yeah, people say rad all the time. Yep. But that's called a radical right there. This doesn't always have to be a square root, but if there's no number associated with it, not inside here, but if there's no number associated with it, like right out here, then it's considered to be a square root. So let me just show you a few things. So that would be a square root. Thank you. Oops, I didn't hook my microphone up to me. That should be better. This would be a square root. Now you could put a little 2 right there. We don't usually do that. This kind of gets in the way because we use square roots so often that we don't usually put the 2 there, but you could put it there. But here's some other radicals and some other roots. Okay, so this is a square root. This is called a cubed root. Okay, C-U-B-E-D, cubed root. Put a 3 right there. We'll talk about what all that stuff means here in a second. I think on this lesson we're just talking about square roots. We're not talking about cubed roots, but I just thought it'd be good to see. Now, once you go beyond 3, if I put like a 4 right there, we just call this a 4th root. Okay, and then so on. If you put a little 5 on there, it's a 5th root, 6th root, 7th root, and so on. All right, that's what that stuff means right there. Normally, again, if it's a square root, we don't usually put the 2 there. So if there's no number out in front or just kind of small, it's not really out in front. It's little, it's tiny, it's kind of in the crook of that little V looking thing. If there's no number there, that's a square root. So what in the world does square root mean? Well, I bet you already know because you guys are seniors, and at this point, you've probably done a ton of square root stuff. So I'll give you a little definition they give in the book. So here's a little definition. It says if, let's see what it says, b squared equals a, then b is equal to the square root of a. All right, so, oops. Tell you what, let's do this. Oh, that didn't work. How do I make a rectangle in this? Oh, well, I'll have to figure out how to make a rectangle. Oh, here it is. What's the keyboard shortcut? Oh, it's M. Why is it M for rectangle? Isn't that weird? So there you go. There's a nice rectangle for you. All right, so we'll put that in a little box. So if b squared equals a, then b equals the square root of a. So really, what was the math involved here? If we wanted to solve for b, what's happening to the b? Is something being multiplied? Is it being multiplied by a 2? Is that what's going on here? No, what's going on here? What are you doing to the b? You're squaring it, multiplying by itself, right? You're squaring it. So what do you think the opposite of squaring something is? We just talked about it. What is it? The square root, okay? So remember, if you have something like this, if you have like 3x equals 12, what's going on here? It's 3 times x, isn't it? What is the 3 doing to the x? It's being multiplied, so how do we get rid of it? We always do the opposite. What's the opposite of multiplication? It's division, all right? So if you go here, the same basic rule applies. what's happening to this b? If I want to get b by itself, what's happening to it? It's being squared. What's the opposite of squaring something? Taking the square root of it. So let's just show the math here. B squared equals a. So what would I do? I would take the square root of this. I'd take the square root of that. Now, they're opposites of each other. The square and the square root, they're opposites. They undo each other. A lot of mathematicians would say, okay? They undo each other. So they actually kind of cancel each other out, if you want to think of it that way, all right? They cancel each other out. So the square root and the square kind of cancel each other out, and what are you left with then? Just a b. What's over here? It's the square root of a, all right? So what in the world does a square root mean? So if you had something like this, a 9. So if I said, what is the square root of 9? Everybody should be able to do that in their head. But I'm just, again, this is basics. This is review. We're going to take a while, several weeks, on just doing some basic review stuff, just to make sure that you get all this straight in your head. So what are you doing when you take the square root of a number? You're asking yourself, what number times itself is equal to 9 times itself? So what times itself is 9? 3 is, right? 3 times 3 is 9. So the square root of 9 is 3. Everybody with me on that? You could have written it like this if you wanted to, just to kind of see it. Watch. 9 is 3 times 3, isn't it? Would you agree? Okay. And what's anything times itself? What do? We square it. I'm just showing you. You don't have to. This is not like steps to do the problem. If I asked you to do the square root of 9, this is one case where you could just write down the answer and that's it. All right. You don't have to show any work. I'm just showing you just some real basic stuff here. But look at this. 3 squared is 9. The square root of 9 is 3. What happens to that square root? Oops, I missed it. What happens to that square root and that square? They cancel each other out, right? So if I gave, now you knew what this was in your head. You could just look at it, bam, you knew it, no big deal. But what if I gave you this? What if I said, what is the square root of like 37 squared? Do you have to put in your calculator 37 squared and then take the square root of it? Do you have to do that here? No, because you see a square root, you see a squared, so you know what happens to the square root and the squared. They cancel each other out. So what is the answer to this thing right here without really using a calculator, without even thinking that much? What would the answer to this be? Somebody tell me. Just 37 is all it is. Okay? So that would be 37. Right? Again, because the square root and the square, they undo each other, they cancel each other out, and so you're left with just something pretty simple. Everybody with me on that? All right. What if you had something like this? What if you had x to the 4th and then the square root of it? So again, what are you doing? You're asking yourself, what times itself is equal to x to the 4th? X squared, that's right. Because if you look at it, again, you may not have to write this out. I'm just doing this. This is all what's going on inside my head, all right? So right there, x to the 2nd times x to the 2nd, or x squared times x squared is x to the 4th. We went over that lesson before. You add the exponents, all right? So that's basically what's happening right here. So what times itself? Or you could look at it like this. Again, this is just kind of what's going on in my head, all right? It's x squared. So it's x squared times itself. So it's really x squared what? Squared. Do you see that? And then what happens here? This square root cancels out with this squared. So what are you left with? It's just x squared. Again, you could probably do that in your head. Does that make any sense? All right. They don't say this in the book, but I'm going to say it here. Here's another way to write something squared. Like if I put, I'm sorry, not x squared, square root. If I have this, here's another way to write the square root of x. Now, it's not x squared. It's completely different. They're completely opposites. But have you ever seen this? Have a fraction for an exponent, right? When you're in Algebra 1, you don't really see that. When you start getting in Algebra 2, they start talking about this stuff. So you probably saw this in Algebra 2. So the square root of x is the same thing as x to the 1/2 power, okay? It's not to the 1 power, okay? X to the 1st would just be x. It's not to the 2nd power. That would be x squared. This is to the 1/2 power. So that's pretty important right there, all right? Again, they don't say that in the book, but eventually we'll get to that and we'll see it later on. So I figure since we're talking about square roots, we might as well throw that in there. All right. There's nothing new so far, is there? There's a couple rules, though. So here's some rules for square roots. There's 4 things. I took this right from the book, so it's in the book somewhere. I'm just looking at my notes. I don't know what page it's on, but you could find it in that section. So you cannot have a negative number. So no negative numbers inside a square root. No negatives. I'll just put negatives inside a square root. Okay? So you cannot have the square root of -3. That does not exist. Not as far as real numbers are concerned. In Algebra 2, did you guys do imaginary numbers? I think you did, right? So we're not going to talk about that right now, I don't believe. No, we're not. So I'm not going to talk about that. But this kind of does exist in the imaginary number realm. But in real numbers, when we're talking about real numbers, if you put this in your calculator and you put the square root of any negative number, it's going to say error in your calculator. Or we say that this is undefined. So there are no real numbers. So basically, for right now anyway, you can't do that. All right. Later on, we're going to talk about imaginary numbers, complex numbers. Then you can do stuff with this. But for right now, you can't have negative numbers inside a square root. Can you have negative numbers inside a cube root? This is off track a little bit. It's not in the book. But can you? That's supposed to be an 8. My 8s are terrible. The cube root of a -8. So what does cube root mean? Cube root means what number times itself 3 times. Okay, 3 of the same numbers, the exact same numbers multiplied together does equal -8. Is there a number, if I multiply it by itself 3 times, am I going to get -8? There's not? -2. -2 times -2 is what? Talk to me. +4. +4 times -2 is -8. So can you have a negative inside of a cube root? Yeah, you can. Because, exactly right. I was going to get to that. It's a good point. When you have odd roots, you can have negatives inside of odd roots. But you cannot have negatives inside of even roots. You follow me? You can't have it inside of a 4th root, a 6th root, an 8th root. You can't do that. But you can have it inside of an odd root. Because remember, when I multiply an odd number of negatives, my answer is always negative. Okay? All right, enough of that. Sometimes I go on little rabbit trails here, get so excited. All right, so if you have the square root of 0, you can do that because 0 times 0 equals 0. It's supposed to be a square root. There we go. All right, so that's true. What else? This says the square root of a positive number is always positive. All right, so that's pretty easy. So I'm going to put a little positive in there. So if I take a square root of any positive number, it's always going to be positive. Because I can't take a square root of a negative number anyway, right? So anytime I get a square root, I'm always going to get a positive number. Okay, so if I ask you what's the square root of something, don't ever give me a negative number because it won't work. Okay, the square root of any positive number, because we're not doing negative numbers, right? So, but the square root of any positive number is always going to be positive. All right, let's do another one. This is the last one. Basically, I already talked about this, but this is one of their rules. They put the square root of c and then a squared on the outside. This is a little bit different because we had the square in the inside of this. They still undo each other. If I square a square root, it just becomes the number that's inside of there. Okay, because I'm just multiplying it by itself. All right, enough of that. We kind of talked about that already. So let's do a couple examples. Tired of this yellow. Let's do another one. Let's do this light green. All right, here's super easy. It's a positive number, so we know it's going to be positive. So what number times itself is 64? Just +8. That's all there is to it, okay? We're not taking half of the number. I've seen kids try to do that. For some reason, they think you're taking half of it. You're not. You're asking yourself what number times itself is equal to 64, and it's 8, and it's always positive, okay? If you have a negative inside there, for right now, you just say it's undefined, okay? So if I had the square root of -3, what would your answer be? Undefined. later on, we will deal with this, like we said earlier. Let's do a couple fractions. So let's see the rule for a fraction. What if you had 1 over 16? What in the world is that? Well, let me go through just a little rule that we didn't really talk about. Girls, I'm up here. Don't worry about the goat. So right here, watch. If you take the square root of a fraction, it's basically the same thing as taking the square root of the top and then the square root of the bottom. If you can think of it that way, it's going to make things a little easier for you. Because I don't want to think what times what is 1 over 16. I don't know. To me, that's just a little more complicated. I mean, I could probably figure that out. But if it's a fraction, this is what I'm going to do. I'm going to take the fraction. I'm going to take the square root of the top, take the square root of the bottom. Now, in fractions, I don't know if you remember when we, back in, I don't know, Algebra 1 probably, that you're not supposed to take the square root of the denominator, okay? It's not simplified if you take the square root of a denominator. They don't like that. There's whole sections, whole homework problems where you're going to have to get rid of the fraction in the denominator. But right now we made it super easy because it comes out to a whole number. So what's the square root of 1? What times itself is equal to 1? Talk to me. It's just 1, yeah. So the square root of 1 is 1 over square root of 16 is, it's not 8. Remember, we're not taking half of it. What number times itself is equal to 16? It's 4. Okay, it's not 8, right? The square root of 64 is 8. So the square root of 16 is 4. And that's it. You got whole numbers on the top and the bottom, and you just keep it like that. It's as simple as that. All right? There is a trick. I don't believe they're going to do it in this section. Nope, they're not. But there is a trick to get rid of a square root in the denominator because mathematicians just said, we don't like that. We don't want square roots or any root in the denominator, all right? But we'll deal with that some other time. We're not going to deal with that right now. All right, here's one. Now, if I just ask you that, that's supposed to be a 1. If I just ask you that, I don't think I could do that in my head. You probably have to put that in a calculator and get some answer, but that's not what they're asking. They're asking this, and this you can do in your head. You don't have to really do any math at all. So what happens with the square and the square root? What do they do? Well, it's a 1.4. It's 1 point, whoops, I made that even worse. It's 1.4, right? Because what happens to the square and the square root? What do they do to each other? I've said it like 10 times today. They cancel each other out. They undo each other, okay? All right, so the square and the square root get rid of each other, so I'm just left with what's ever inside of there. So I just have 1.4, and that's as easy as that is. It looks complicated at first, but you're like, oh yeah, I remember the rule. They cancel each other out, bam, bam, they go, and I got 1.4. Pretty simple stuff, isn't it? Yeah, people make square roots out to be really complicated. If you can remember the basic rules for square roots, how to deal with them, they're really not that hard at all, okay? Let's do a couple more things, and then we will finish up. Remember we talked about absolute value? So what is the absolute value of -3? Just as a review. What's that? It's just +3. What if I ask you, what's the absolute value of +3? What's that? It's just 3, okay? Absolute value is always positive. So do you remember what we said about the square root? Since we always deal with positive numbers inside square roots, the square root of a positive number is always what? Positive. Isn't that kind of like absolute value, right? Where the absolute value of any number, whether it's negative or positive, is always a positive number. Agreed with that? So if you have something like this, if you have the square root, and this basically is just another way to say that A is always going to be positive, all right? So it doesn't matter what number is in here. If I take the square root of it, I'm always going to get a positive number. So this is how they write it. All right, put that in a box because that's pretty important, okay? So if I take the square root of a square, I'm always going to get a positive number. And how do I make sure, how mathematically do I show I'm always going to get a positive number? I stick in an absolute value, right? So I'm always going to get a positive number. You with me on that? That's basically all that's saying. It's really not that big of a deal. I'll do a couple examples and we'll be finished. Today was pretty easy, wasn't it? So what if I had 2.3? We've kind of done this already. And that's a square right there. Let's extend that little square root thing. Now we know what this is off the top of our head, but if you put it in this, What does this mean? It means it's the absolute value of 2.3, which is always going to give you a positive answer, okay? To tell you the truth, you don't really have to show this step. It's not that big of a deal, okay? If I gave you something like this problem right here, just write 2.3 and you'll be done. That's it. They give you some more stuff in here, but I'm not going to worry about that. All right, you got some time here. When do we get out of here? Like 5 of? Yeah, 55? Yeah, we got plenty of time. So I bet you could get almost all of these done. So this is some classwork for you. Try to get it done. All right, so it's section R.2, part 2, because you've already turned in part 1. And we're going to do pages 27 and 28. And we're going to do numbers 85 to 107. And sounds like a lot, but we're only doing the odds, so it's really not that many. So it's probably, I don't know, what is that? Less than 10, probably 9, 10 problems, something like that. All right. There it is. Why don't we get this done in class today? That'd be nice, wouldn't it? All right, get that done. You don't have to worry about it. If you don't finish it in class, it's not officially homework because, but you do have an extra day because we don't have class tomorrow. So get it done today. All right, so this is classwork. Get it done today. All right. Now we'll turn it in on Wednesday, but get it done today. Yes, you may. All right, that's it for today.